Hello everyone. Welcome to Dr. Carminati, AI, Cybersecurity and Quantum Computing, where we break down complex technological ideas and explore how they shape our world. Today, we're diving into a fascinating topic. Titans, learning to memorize at test time. Inspired by an insightful paper you can find on the link located in the description section below. If you're curious about how large language models, LLMs, struggle with memory compared to humans, and the groundbreaking methods being developed to bridge this gap, you're in the right place. Stick around as we unravel this concept step by step. And hey, if you're enjoying these deep dives into AI, don't forget to like, comment, and subscribe to the channel. Your support helps us continue creating engaging content for all of you. Let's begin by understanding the key question. Why do humans excel at specific types of memory tasks that LLMs struggle with? Human memory is incredibly nuanced and adaptive. It allows us to recall detailed information from years ago or recognize patterns and meanings from experiences we've had only once. This adaptability comes from the intricate interplay between short-term memory, long-term memory, and a contextual understanding of the world. For example, if someone tells you a story, you remember not only the words but also their tone, expressions, and the emotions behind them. In contrast, large language models, which power many of the AI tools we use, rely on an entirely different mechanism. These models are trained on massive datasets and use statistical patterns to predict and generate text. While they can recall facts and context within their training, they cannot dynamically encode and retrieve specific memories from interactions they've just experienced. This limitation becomes evident when they encounter unseen or rare information during testing. So why the gap? At the core, it's about how memory is structured and accessed. Human memory integrates new information dynamically, tying it to previous experiences and real-time understanding. LLMs, however, function more like pre-programmed systems. They don't inherently remember past interactions unless explicitly designed to do so. And even then, their memory mechanisms are rudimentary compared to our brain's sophisticated neural networks. The limitations of LLM memory can be attributed to several factors. 1. Fixed parameters. Once trained, most LLMs rely on fixed parameters to generate responses. These parameters are determined by their training data, and while they encode vast amounts of information, they're not designed to adapt or learn after training. 2. Lack of episodic memory. Humans use episodic memory to store unique experiences. For instance, you remember a specific birthday celebration because your brain encodes the details of that event. LLMs, on the other hand, lack this mechanism. They treat each query independently, without any context of prior interactions, unless specifically engineered to track it. 3. Data limitations. Human memory thrives on the richness of real-world interactions, complete with sensory and emotional dimensions. 3. LLMs, however, learn from textual data, which is inherently limited to the patterns and information within it. Enter the concept of Titans, learning to memorize at test time. This framework addresses the limitations we've discussed and proposes an innovative approach to memory and machine learning. But how does it work? Let's break it down. Traditional training methods involve exposing a model to data during a predefined training phase. Once this phase is complete, the model enters the test phase, where it applies what it has learned. In this setup, the model cannot dynamically update its knowledge or adapt to new information during testing. The Titans framework flips this approach by enabling models to learn during the test phase. Imagine a system that can actively encode and retrieve information from test-time interactions, much like how humans continuously adapt and refine their understanding in real-world scenarios. This is achieved through techniques such as 1. Dynamic parameter updates. Instead of relying solely on fixed parameters, the Titans framework introduces mechanisms for on-the-fly updates, allowing the model to adapt based on test-time data. 2. Memory augmentation. By incorporating external memory modules, the model can store and retrieve information more effectively, mimicking the episodic memory humans rely on. 3. Meta-learning. This approach trains the model to learn how to learn, enabling it to generalize across tasks and adapt more efficiently to new scenarios. Now that we understand how Titans work, let's explore their potential impact. The ability of LLMs to memorize and adapt at test time could revolutionize fields like personalized education, real-time medical diagnostics, and dynamic customer service. For example, 1. In education, a system powered by Titans could tailor lessons to individual students by remembering their learning styles and adapting the content accordingly. 2. In healthcare, it could analyze patient data during consultations and provide real-time, personalized insights. 3. In customer support, it could offer more human-like interactions by recalling past conversations and understanding user preferences. While the Titans framework holds immense promise, it also raises critical challenges and ethical questions. How do we ensure that test-time learning doesn't introduce biases or errors? What safeguards can we put in place to prevent the misuse of dynamically learned information? Researchers and developers must address these questions as they refine these technologies. Additionally, the computational cost of enabling test-time learning is significant. Models that incorporate dynamic updates and memory modules require more resources, which could limit their scalability. Balancing efficiency and effectiveness will be crucial to making Titans practical for widespread use. The journey to achieving human-like memory in AI is just beginning, and the Titans framework is a significant step forward. By enabling models to memorize at test time, we're not just enhancing their performance, we're redefining the possibilities of what AI can achieve. Imagine a future where AI systems understand and adapt to our needs in ways that feel intuitive and seamless, empowering us to tackle complex challenges with unprecedented efficiency. That's a wrap on today's deep dive into the Titans framework and its implications for memory and LLMs. I hope this discussion has sparked your curiosity and provided a clearer understanding of this groundbreaking research. If you have questions or thoughts, I'd love to hear them. Please drop a comment below, and let's keep the conversation going. Remember to like this video if you found it insightful, and subscribe to the channel for more explorations into the world of AI, cybersecurity, and quantum computing. Your engagement helps us grow and bring you more content like this. Until next time, take care and stay curious.